In this session, we will see introduction to sheet metal design. So, sheet metal design in CATIA is a specific module that allows designer and engineer to create manipulate sheet metal parts. So, we will see the sheet metal design in the CATIA user interface. So, what are the key features? We will see them first. First is the sheet metal parameters. There are sheet metal parameters like thickness. Okay, so then there is a design features, pen table, unfolding, folding, and flattening, assembly integration, drafting, and documentation. So these are the key features of CATIA sheet metal. So this is the workbench or user interface of sheet metal design workbench. We will see this. First is the sheet metal parameters. So this is the very basic, or you can say the first step in the sheet metal design. Sheet metal parameters. You can change the parameters of the sheet metal. Parameters like thickness and defaulted bend radius can be changes. Okay. So we'll see this one by one. These are the steps. Okay. Wall definition. We'll see one by one. Okay. So first one is the how to access the sheet metal. So to access the sheet metal workbench in the CATIA V5 software, go to start menu bar, then there is mechanical design, and then go to generative sheet metal design. Okay, click on generative sheet metal design, click OK. So this will create a open the user interface of generative sheet metal design in CATIA. We will simply close this. I have open already this sheet metal design, so we will work in this. Okay, simply delete this. So the first in sheet metal design is this toolbar, the very first option, sheet metal parameters. We have to first adjust the sheet metal parameters in the dialog box. So the thickness is 2 mm and bend radius 4 mm. You can change this. Then there is a bend extremities, bend allowance. Okay, bend allowance is the key factor. Click OK, and now the options will be open. So very first step is to adjust the sheet metal parameters. So the very first is this wall. Okay, so click on wall, this toolbar. What do we have to select? A profile. So I will select this profile which I have created on this plane. Okay, this vertical horizontal. Then tangent to, if there is any tangent, you can select that. Invert material side. See this material side is now downward, the profile it is now upward. So there are this. Okay, see this, stretch at middle position, and the first is okay. It will create a symmetry of the material apply. Simply click on OK, and this will create the sheet metal. Okay, so the next step, we will create a wall on edge. Select the wall on edge feature. What we have to select? We have to select the edge. So I will select this edge. See, this wall has been created. Okay, so what parameters can we change? I will change this angle. So we can change the angle from here or here. Okay, next is height. So we can change the height also. This is the drag. We can drag it, or you can change it from here. Okay, so this is the final wall on edge example. You can apply this on bend. So bend will be created here. See, this is the bend we have defined in this sheet metal parameters. Okay, if you don't want bend, you can simply click on without bend. Okay, see, this wall on edge has been created. So you, if you want display style different, you can click on this. Okay, so next we will see extrusion command. We will see the next. For this, I will simply create a new sketch on this plane. Okay, go to sketch and create a profile. You can create an open profile. Okay, so I will create a random profile. Exit the sketcher. Okay, So I will go to extrusion in the wall toolbar. I will select this profile. You can see this. Select the profile. Okay. So the direction is that one. So if you want to invert the direction, invert the material side. Anything you can do. It's now in inward, now in outward. Okay. You can also change the limits. Okay. It's the extrusion height of the sheet metal profile. Click on OK. This will create a profile with the bends that has been we have created in the sheet metal parameters. Okay, so 4 mm radius bend will be applied. The next will be flange. So we will see flange one by one. So the first one is the first one is flange. For flange, we will create a sheet metal wall. Okay, and what we have to select a spline, or you can select the edge also. In this, we can change the parameters like length. Okay, so length will be, see this, length will be changing. Then there is angle, we can also change the angle between these two surfaces. Then we can change radius. This is the bend radius, we can also change that parameter in the flange definition. Simply click on OK, and this is the flange. If you select on OK, this is the flange will be created. Okay, so the next one will be seeing is that hem. So to access the hem in the wall toolbar, go to the hem command, select the edge you want hem. See this. Okay, so U section has been created, or U bend has been created on the sheet metal edge. You can change the radius also. Okay, then you can change the height of that sheet metal flap. Okay, click on OK. See this. Now the next command will be this teardrop. To teardrop, same, click on edge, select the edge. Okay, if you don't want this, just simply go to this and select another one. Okay, teardrop I want from this outward. Okay, so you can change the radius, change the direction, and change the radius or length. Click OK. So this is the teardrop flange. The next is the, what is the next is the user flange. Okay, so for the user flange, okay, so for the user flange I will create on this. Okay, so I will create an user flange on this edge. I want to create a user flange with a defined profile. So what is the user defined flange? Go to user defined flange. Okay, it says select the spline, so I will select this spline. Okay, the profile should be normal to this spline, so I will create a sketch on this surface. Okay, on this surface I want to create a sketch, so I will create the sketch. I will simply create a spline, sorry, not spline, I will create an arc. Okay, and then I will create a line tangent to that arc. So what we are doing, we are just creating a user defined flange. Okay, so I want flange just like this. I want a flange, so what this point and this point should be coincide, so I will simply coincide that point, coincidence. Okay, I will also tangent, I will apply tangency to this line and this arc. Okay, tangency. Okay, simply exit the sketch part. Sorry, I have selected the profile and edge. So what happened, the edge has been selected out this, I want this, so simply go to edge. Okay, remove all, I will select this edge and profile will be created. Okay, something is happens very wrong. Okay, I will see this, I will edit the sketch. I think something is very, okay, so tangent scene not applied to this. line. I will apply tangency, and simply I will okay, I will delete this, and I will create a line. Okay, I will okay exit the sketcher part. Okay, so I have created the sketch. I will exit the sketcher part. User defined spline. Okay, spline selection, I will select this spline, and then profile I will select this profile. Okay, so this is the user defined flange definition. Click OK. So this is how you can create a flange by user defined sketch. Okay, so in today's session I have completed the wall toolbar. So next we will see, okay, so first is creating wall. You can see the steps. Okay, create a wall edge. How to create a wall edge? Then extrusion. This is the extrusion. This task shows you how to create a wall by extrusion process by profile. Extrude the profile. Okay, the next one is flange. Okay, so this is the flange definition. Rolled walls. So we will see the rolled walls. So what is the rolled wall? So where is the very first is the hopper. In the rolled wall toolbar, very first is the hopper, then the rolled wall command. So these are the two commands in the rolled wall toolbar. So to access the roll wall toolbar, here is the roll wall toolbar. You can access it. First one is the hopper. So for the hopper, go to the hopper. This is the hopper definition toolbar or hopper definition dialog box. For the hopper definition, you have to create a plane offset from each other and two different sketches. Okay, so we will select the sketches. Okay, go to create a multi-section surface. Okay, just right click on it, create multi-section surface, then select the first profile, then second profile, match the closing points, click on OK. This will create the surface. Okay, reference wire, you can create a reference wire. Okay, so we have created this. We just have to edit this. Okay, edit multi-section, and what we have to do, we have to make sure this guide, select the guide, then say OK. Okay, so this is the reference wire. In the reference wire we will select this guide. There is a guide here. I will show that to you. Invariant point, so we will select the invariant point. So right click on the invariant point, create point. I will create a point on this line. Okay, line I have been created from first point and second point on the both the curve. Okay, so I will select the line. Okay, so here is the point. So I want a ratio of 0 0.5. Okay, so I will click on preview. See, this point has been created. Okay, see this. So this is the surfacing hopper. Okay, so I will create OK. So this is how you can create a hopper in the roll wall toolbar. So hopper has been completed. So we will see the next one, which is the roll wall. Okay, so for the roll wall I have created another sketch. So this is the sketch. So you have to create this type of sketch for the roll wall. Okay, so okay, the hopper, for the hopper you have to create a sketch circle, then the next sketch to the offset of for this the circle that has been created for on the offset of plane of that. Okay, and then there is a this point, this second point, and a line joining both the point. So this is a spline, this is first section, second section. Okay, so roll wall definition, we will see the roll wall definition. This is the roll wall definition dialog box. So you have to create this type of sketch, select the sketch. Okay, and the wall will be created. This is the rolled wall. You can invert the, okay, symmetrical thickness, you can give the symmetrical thickness. I will zoom. Okay, so the orange one is the profile and red one is the preview of the rolled wall. Mirrored extend. Okay, so mirrored extend mean upward and downward will be the same parameter. So if you 141 upside or 141 downside, so you can change. Okay, so this is how you can create a rolled wall in CATIA generative sheet metal designing. Okay, so we have seen the hopper and rolled wall. Now we will see the bending toolbar. We will see the bending toolbar. For the bending toolbar, you can access the bending toolbar from here. This is the bending toolbar. Okay, the first one we will see the bend. So for this, we will create another sketch. I will create a sketch on a plane. Simple sketch. I will create a center rectangle. Okay, exit the sketcher. This is a random sketch, so don't worry. Okay, so this is the sketch. I will create a wall. Okay, see this. So the first option in bending is a bend. For this, I want to select a edge similar to what we select on ball on edge. So I will select the edge. If this is not happening, it's okay. So let's create from here. Okay, so for the bend we have to select support 1. So this is the first support, then support 2. So what will be the support 2? Support 2 will be this. Okay, so this is the support and there is not a bend. See this, there is no bend. So what will it will do, it will create a bend on both the surface. So for your easily understanding, I will redo this process. Okay, so this is the first, and after applying bend, okay, so bend will be applied of 4 mm, which we have. Okay, sheet metal parameters. So the next one is conical bend. Go to the conical bend. Okay, so I want this to be conical one, so I will simply redo this and I will do the process similar. First support, then second support, and you can create a fourth. So we can give a left radius. See this is the left radius, so I will give a left radius of 2 mm and the right one this one. Okay, so that this one should be more, so I will give for example I will give 10. Okay, a 10 will be here is 7. Preview. Okay, see this is the 7 mm radius, this is the 2 mm radius. Click on OK. So this is the conical bend. Okay, so this is the conical bend. Okay, the next option we will see bend from flat. For bend from flat, I will create a bend from this one. We will see bend from flat. Go to bend from flat, bend from flat definition. So we have to select a profile. So profile, for profile we will create a profile on this surface. I will show you how to create a profile. Okay, normal to sketch. I will create a line. I will simply create a line, then another line for your simply understanding it. Okay, so these are the lines. I will coincide this point with this edge. Coincidence. Okay, then another coincidence. Okay, then another coincidence similar to first line. Okay, then, so I am showing you bend from flat command. Okay, simply exit it. See this is the, so fixed point, it have selected this as a fixed point. So what will happen, it will bend on this line, then this line. So these both are the bends that are being created. So we will just see this. Okay, preview. So you can see that first on this and then second. Okay, so this is the fixed point and it is just rotating. Okay, so you can create this series, click on OK, and the bend will be applied. Okay, so the next we will see folding, unfolding. So go to the unfolding, the reference face. I will select this as a reference face and unfold faces. So I want to unfold faces. So I want to unfold this, or okay, so I want to unfold this. Okay, so we will see this folding, unfolding, unfolding. I will go to unfolding and reference faces. So reference face I want this. Okay, an unfolded face. Okay, so this I want as unfold. Okay, remaining I want this as unfold. I want to unfold this bend, then I want to unfold this bend to the conical. Okay, you can see that. Okay, now you can see this. So this is the reference face, this will be remain as it is, and I will unfold this bend and this bend. Preview, see this has been okay, simply you can see this. So how it was first, it was like this. I have unfolded this bend and this bend. Okay, control Y. Okay, see this. So this is a unfolding, so I want to unfold. Similar to unfolding, we can also fold the bends. Okay, so folding, similar step. I want to reference face. So okay, so I want reference face as this, and then fold face. So I want to fold, I want to fold this bend, I want to fold this bend, then also this. So I will select this. So these two faces I want to fold. So I think there is some issue. I will select this, and select. Okay, I want to fold this one, conical bend, preview. Okay, so this cannot be folded, it says. Okay, we will unselect this and I will simply reference face as this. Then I want to fold face. Okay, so this is only folded, so I will simply this as a reference surface. Then I will select fold faces. So fold faces I will select this one. Okay, so then click on OK. So it will do, it will fold at this bending. Okay, so what you can see the changes. Okay, so we have we have completed the bending toolbar. These three options: first is the bend, conical bend and normal bend, then bend from flat, and then folding, unfolding. Okay, so this folded, unfolded view we can see, folded, unfolded. Okay, so that's all for today, and thank you.